Hi, and welcome to this fifth IB Maths Intense session on the binomial theorem. In this particular video, I'm going to be looking at a specific type of question where we're asked to approximate values using a binomial expansion. And this is where we can calculate seemingly complicated or difficult calculations using a binomial expansion. Let me give you an example of the sort of question I mean. So in this question, nice straightforward question, we're asked firstly just to find the first three terms in an expansion of 1 plus 2x to the 8, and then we're asked to substitute the value of x equals 0.01 to find an approximation to 1.02 to the 8 to two decimal places. If you were to substitute x equals 0.01 into those brackets, you would see that you're expanding out 1 plus 2 lots of 0.01, which is 1.02 to the power of 8. So whatever we've got as our expansion will give us an approximation of 1.02 to the 8. So we answer the question in two parts. Firstly, we find the first three terms in the expansion, and that should be something you're really good at now because we've done lots of that. So our first term will be simply 1. Second term will be 8c1 times 2x. Well, 8c1 is 8, and 2x, that's 16x. Nice and straightforward. And the third term will be 8c2, which is 28, and then I'll write this down in full so you can see 8c2 and then times 2x all squared. And then we're going to stop there because we're only asked to find the first three terms. 8c2, go back to the earlier videos if you can't remember how to calculate that by numerical methods yourself without a calculator. But 8c2 is 28. So that becomes 1 plus 16x plus 28 times 4 is 112x squared. And I'm not going any further than that because the question doesn't want me to. Now by substituting x equals 0.01, I will find an approximation to 1.02 to the power of 8. Let's do that. We can say 1.02 to the power of 8 is approximately equal to 1 plus 16 times 0.01 plus 112 times 0.01 all squared, and then that would continue. Now, given that I want to round to two decimal places, to do this calculation by manual methods, I'm going to write my solutions to each of those terms in nice columns. So I've got 1.000. I'm only going to write to three decimal places because I'm rounding to 2. 16 times 0.01, well, multiplying by 0.01 is the same as dividing by 100. So I'd end up with 0.16, and then 112 times 0.01 squared, that's dividing by 100 twice. I would end up with 0.0112. Just adding those together, I end up with 1.1712. So my approximation to two decimal places is 1.17. And if you work that out in your calculator, you'll see that indeed 1.02 to the power of 8 is 1.17 to two decimal places. That's a really cool way of doing a complicated piece of maths without a calculator, and you might have to on the higher level non-calculator paper. Let's have a look at a slightly more complicated question, but using the same principle. This time it says find the first four terms in the expansion of 2 minus 2x to the 10, and it says this time put x equals 0.01 to find an approximation to 1.98 to the power of 10 correct to the nearest whole number. So this is a little bit more difficult because the numbers are more tricky, but let's first of all write down the first four terms in the expansion. So this time we're going to get 2 to the power of 10 because it's and 10c0, 2 to the 10. And then the next term will be 2 to the power of 10c1, sorry, 2 to the power of 9, and then minus 2x just to the power of 1. That's the second term. Third term, 10c2, 2 to the power of 8, minus 2x all squared, and then finally 10c3, 2 to the 7, and minus 2x all to the power of 3. And that would carry on, but we don't need to because we're only asked for the first 4 terms. Let's resolve those then. So 2 to the 10, using the calculator, 1024. 10c1 is 10. And let's multiply that by, well, you'll see in each of these, 2 to the 9 and then times 10 again. Well, we're ending up with 2 to the 10 every time. So that's, again, 1024. So I'm going to multiply that by 10, 10240, and x. Now, I've made a mistake there, as you probably spotted, because that's negative x. So what I need to do is make that sign negative there. It's 1024 minus 10240x. Next, I've got 10c2, again multiplied by 2 to the 10. Well, 10c2 is 45, and 2 to the 8 is 1024. Multiply those two together to get 46080. And this time it's x squared and it's positive because I'm multiplying minus 2x by minus 2x. Next time is going to be a zero. Is going to be a negative because it's a cubed of a negative number. I've got 2 to the 10 again, and I've got 10c3. 10c3 is 120 multiplied by 1024 gives me 122,880 x cubed, and then that would continue. Now, I found the first 4 terms. There they are. Now I'm going to substitute in x equals 0.01. So 1.98 to the 10 can be approximated to 1024 minus 10240 times 0.01 plus 46080 0.01 squared minus 122,880 0.013. This is a little bit painful, isn't it, having to write everything down, but do that in the exam because it won't do any harm at all. Now, let's just work out those values and then we can do a little bit of reckoning. So this gives us 1024. I'm then dividing 10,240 by 100 when I multiply by 0.01, so that will give me 102.40. This time I'm dividing by 100 twice, so I'll end up with 4.608. And then here I'm dividing by 100 3 times, which will give me minus 0.122,880. Now, to make that calculation easier, I'm going to take all the positive terms and add them together. So that gives me 1024 plus 4.6080, which gives me 1028.608. And then my subtraction, let's bring those two together, 102.40 plus 0.12280 and so on is 102.51228 and so on. So I can forget about some of that because I'm only interested in an answer to the nearest whole number. So if I just take some of the calculation away, I can then, sorry, that should be 5122. Great, okay, let's do that. So 80 take away 22 is 58, 60 take away 59 is 9, and 1028 subtract 102 is 926. So to the nearest whole number, we've got an answer of 926, which I think you'll agree, we wouldn't have been able to do that just in our heads, would we? 1.98 to the power of 10. Very good. Let's move on. A third example question then. Expand 2x plus 3y to the 5, hence find the value of 2.03 to the power of 5, correct to 5 decimal places. Well, you'll see here that we're not told this time what values to substitute in, but hopefully that will be fairly apparent from the number that we're given to find. And of course here there are two terms, x and y, which we'll require to substitute in. So that's makes this more complicated than the other two questions. But let's do what it says, and the first thing is let's expand that out. So we know, using our binomial expansion, the formula at the bottom, that would be 2x to the power of 5 plus, and then 5c1, which is 5, 2x to the 4 times 3y. Then the third term, using Pascal's triangle, is 10, 5c2, 2x to the 3, 3y squared. And then we've got 10 again as a coefficient, 2x squared, 3y to the 4, and then 5 again, symmetrical, times 2x times 3y. Sorry, that earlier term there shouldn't have been to the power of 4. Should have been to the 3. And then we should have 3y to the power of 4 here. And then the final term is 3y all to the power of 5. I'm rushing through this. Of course, when you're doing this in the exam, make sure you check that you don't make silly mistakes like the one I nearly made there. Now, let's just simplify all of that out. 2 to the power of 5 is 32, so 32x. We've got 2 to the power of 4 times 5 times 3 gives us 240. And that's x to the power of 4, sorry, this should be x to the power of 5, x to the power of 4y, and then the third term, 10 times 2 to the 3 times 3 squared will give us 720. This is x cubed y squared, and then I've got 10 times 2 squared times 3 cubed, which is 1080, and this is x squared y cubed. Then I've got 5 times 2, 10, times 3 to the power of 4, that's 810 altogether, xy to the 4, and then last but not least, 3 to the power of 5 is 243 times y to the power of 5. So there's my expansion, first part of the question. I'll get my marks for that. Then I'm just going to substitute in some values. So 2.03 to the power of 5. Hopefully you can see if I set the value of x equal to 1 and the value of y equal to 0.01, like we did before, then that would give me 2.03 inside the brackets. And that makes things a bit easier because x being equal to 1 suddenly disappears here. And we end up with 2.03 to the 5 is equal to 32 plus 240 times 0.01 plus 720 times 0.01 squared plus 1080, 0.01 cubed plus 810, 0.01 to the power of 4, and then 243, 0.01 to the 5, just squeezing that in at the end. So I'm being asked of 5 decimal places, so I'm going to write each of these terms down here. I'll do them on the left-hand side where I've got a bit of space, and I'll give myself 6 decimal places, 1, 2, 3, 4, 5, 6, so that my rounding is correct. 240 times 0.01 is the same as dividing by 100, so that would end up with 2.40. And I can fill in with zeros there just for completeness. 720, I'm dividing that by 100 twice, so I'd end up with 0.072. And then 1080, dividing that by 100 3 times, I end up with 0.001080. 810, divide that by 100 4 times, 0.000081. So I've already gone past my 5 decimal places. So I'm not going to bother doing 243 to the times 0.01 to the power of 5 because it won't have any impact on my answer to 5 decimal places. So now I can add that lot up, an 8 in there, 8 in there, 0 there, 3 there, 7 there, 4 there, and then 34. So to 5 decimal places, 1, 2, 3, 4, 5 there, we're going to round upwards, so it approximates to 34.47309 to 5 decimal places. Now that is amazing that we can do that without a calculator, especially if we know our Pascal's triangle, and get an answer accurate to 5 decimal places. And if you check that with your calculator, you'll see that that's correct to 5 decimal places. So there we go. Binomial can be used to find approximations, and there's no real trick here apart from obviously do the expansion correctly, and sometimes use your imagination to find how you can get the value that you're being asked to calculate from the two terms by substituting values to the two terms inside the brackets. Keep practicing. Have a look at questions you've got in your textbooks, practice exam questions on that theme. Thank you for watching. Don't forget to like this video, subscribe to the YouTube channel IB Maths Intense, and of course tell your friends I'm here. Drop me an email on ibmathsintense@gmail.com if you've got any requests, any comments, any feedback, if you spotted any mistakes that I made. So enjoy your maths and you take care.